Hey, Bree.
Hi.
Bree, I think you're muted.
There we go. Sorry, I'm late. How's everyone doing?
Good.
Good.
Oh, great.
Good, good.
Good.
You guys ready for some more calculations today?
Yeah.
Okay, let's see. Are we waiting on? Okay. Let's get started. So we did all of assignment number 2 as a class last week. So this week we are going to be calculating the tides using the tide book. So I know most of us will use computers and apps and websites, but we're going to learn how to do it by hand in case we lose power or want to do it by hand. So it is, I don't know, an outdated method, but if you are taking the coastal navigation U.S. sailing test, there will be some of these tables on it. So we're just going to learn how to navigate the tables. Okay, so for today's class, I want to make sure everyone has the printout. It says table 1, or it says table 2, title differences, and then there should be 1, 2, 3, 4, 5, 6 pages. We're going to kind of be referencing this. So have this out during our PowerPoint. Okay.
Bree, excuse me, if we don't have those, would it be on the in the classroom then?
Yes, it would be in the classroom as well.
Okay, thanks.
Let me make sure it's in the classroom. It would be the tide table handouts for 2019. So we're using last year's. Hopefully you guys got it.
I think it was in that packet of stuff you mailed out.
Okay, good.
The original
Good.
mailer. Yeah.
Good. And then we're I guess after our PowerPoint, we're gonna work on the homework, but let's dive into this PowerPoint here. Any questions before we get started?
You said there'd be 3 pages or 6 pages?
So 6 pages, 3 pages front and back.
Okay, I have 3 pages, only one side that were mailed to me in the packet from the school.
Not front and back?
No, they're just one-sided.
I think that's the same thing I got, but I printed out from the classroom.
Okay, that's a mistake then. Yeah, I would print it out from the classroom so you could draw on it.
Yeah, can you, when you have a moment,
oh yeah,
if you can email it to me, I'll print it.
Yeah, sorry
I
about that.
don't have access to the classroom, so.
I forgot to email you today.
No problem, thank you.
So what do you want, Bree? You want a table 1, 2, and 3?
Yes, 6 pages. So table 2 is just 1 page. And then it says Los Angeles Harbor on 4 pages. And then table 3 is just.
Oh, I only have 2 pages for Los Angeles Harbor, but okay. I just have January to June for some reason.
Looks like we lost Bree.
Okay, Terry had some technical difficulties, so we're going to have to share the screen here, but we're good to go. And now Bree's frozen. What a mess. Do you want to bring your computer in and see if you can continue trying? Hey there, Bree, we can see you.
Okay. Okay, good. I was like, whoa, what happened? Okay.
Bad time for the Zoom software update, huh?
I was like, oh
Yeah. I don't know if we have everybody. Tiari is with me. She had a difficult time with the update, and we're like, we didn't want to be late.
no. Okay. Okay. Oh gosh. Okay. We're here now. Okay, so we figured out there was a mistake on the handout that was mailed to you guys. If you go to the Google Classroom, it is 6 pages. So it's 3 pages, but it's front and back 3 pages. So a total of 6 pages. Sorry about that. Okay, so if you haven't printed it out yet, that's okay. We'll go through the PowerPoint, and then during a break or something, you could print it out. So we'll get started on our PowerPoint.
Just a quick question.
Yeah, go ahead.
Normally, about what time during the year they will publish the type book for the following year?
What was the question? What time of the year?
They will publish the this type book.
Oh,
in the following year.
they get published, I want to say in the fall, so probably around October.
I see. Okay.
For the next year.
Okay.
Because you put in your orders, and then I usually get them the end of November, December for the following year.
Okay.
Yeah. And so the annual publications we'd get would be the tide tables, the current tables, the light lists, and the nautical almanac. Those are all annual publications.
Okay.
Okay. But I will show you on here where you could get them digitally. So if you download them, you know, they're PDF, you could download the latest one to your computer or your tablet. But again, to run those computers and tablets, you need power. So if you're in a situation where you don't have power, then the book's handy. But okay. Okay, so today we are talking about tides. We're going to touch a little bit on calculating currents, but we're mainly going to focus on tide. So here's a picture of a very large tide change. And if we remember back to our vocab, we call it the range of tide, is the range from a consecutive tide from a certain high and it falls to a certain low. That is going to be the range, or from a low, it's going to rise to a certain high. That is the range. So some places around the world have very large ranges, and they could result in these, you know, dramatic pictures. Here on the West Coast, our tidal range is pretty small. It's not that big of an issue that we have to worry about. So we're really lucky with that. Okay, so when we talk about tide, going back to our definitions, the tide is that vertical movement of water. So we're just talking about the vertical movement of water. That's all that we're calculating. And we always add this tide to the charted depth. So the charted depth can be changing all along, and we add the tide because the tide kind of covers a region, if you will. And so there's lots of different depths in that area, even though the tide is the same, because we apply that tide to the charted, to the sounding, to the charted depth. So sometimes we can get a negative tide. Doesn't mean we're seeing the ocean floor. It just means that we're below that chart sounding, that whatever is marked on the chart. So when we look at this calculation here, we have our chart depth, and then we add our tide. So say our chart depth is 10 feet, we add a 2-foot tide, and we have actual water depth of 12 feet. Then we have to minus our draft. So the draft is from the water line to the keel. So what is submerged in water? Do we have, you know, a deep draft? Are we concerned, or is it a pretty shallow draft? Depending on what type of boat you're on, you'd have different drafts. And that's where we get our under keel clearance. So that's the important kind of our, what I want to say, our margin of error that we're looking for. You know, we want maybe on a boat that I'm working on, I want at least 5 feet under keel clearance to be safe. Or maybe I'm okay with 2 feet under keel clearance, or maybe I want more of a 10. So that under keel clearance is up to you, but that's kind of how we apply this to our voyage planning. That says, okay, I want an under keel clearance of 5. If my tide goes below, you know, 2 feet in this certain, you know, crossing this bar or something, then I can't go there. So I need to know what my tide is doing so that I have enough under keel clearance, because that's when we run aground, right? When we don't have any under keel clearance. So so that's kind of a little calculation here. So our chart depth plus the tide great. We have 12 feet of water. That doesn't mean there's 12 feet of water under our keel, and that's the important part. Okay, does that make sense? Everyone on board with that? Okay. Okay, so this is
Wait, I'm not done. So the chart datum is that line is your lowest low tide.
Yes.
Your mean lowest low tide.
yes,
Okay.
that's correct.
When you see the chart depth, like it says the chart depth is 20 feet. Is that to the bottom? That's to the floor of the ocean, right?
Yes, so that's what you're sounding.
That's from the chart datum.
To
That's
to
from the
wherever
chart
the
datum,
sea floor is. Yeah. And that's what the sounding is.
Yeah. So when you see like 20 feet, that means it's 20 feet below the mean low water mark.
Correct.
Your
I got a
chart
question,
datum.
Bree.
Okay.
When on that, in the illustration where it has the sender unit, is that measuring straight down, or is it forward looking? Because it seems like if it's just straight down, it could be too late, like if you're going over a rock, you know?
What do you mean?
Well, is it, so it's telling you the depth where it says sender unit CoNav2?
Yeah, yeah,
Okay, is it measuring the depth straight down? Or is it, because it
yes,
seems like it is?
yes.
Oh, it seems like you want it sort of forward looking so you could see sort of where you're headed.
I guess that would depend on what kind of depth sounder you have.
Okay,
But I'm gonna say on most of the ones that I've used, it's below you.
yeah, that
So,
kind of,
so you would see it, and usually, and some of, I'm not gonna say usually, some depth sounders print it out in like a graph or display it in like a little graph form, so you can see it,
yeah,
you know, getting shallower and shallower. So that should be an indication that, or if it gets below, you know, a certain number, then it starts to alarm. And that should be a red flag there. Let me check something real quick. Oops. Oops. Sorry. It's saying my internet is unstable. Can everyone still see me?
Cut in and out every once in a while, but we can still see you.
Okay. Let me be right back real quick. I'm going to go check router thing. Hold on.
I haven't been there before.
Like when you lower the light to it too much, all light to.
Okay.
Little bit more. Yes.
Okay. Okay, it says it's connected. I'm hoping that will work. Okay, let me go back to the PowerPoint. Okay, so we were just talking about our under keel clearance and our drafts. The opposite side of under keel clearance is our bridge clearance. So we got a few bridges in Newport, but some places have a lot of bridges. And especially if you're on a sailboat and you have a tall, you know, vertical draft, then you want to know what the bridge clearances are. And a lot of times there is a, what is this? Like a ruler or like kind of an indication that you could see what the actual clearance is at that specific time that you are approaching the bridge. So it'd be good if you calculated it ahead of time and knew if you would have clearance or not. But a lot of bridges will have that kind of that board, that reference board to look at. So I'm sure you guys have seen those, but so we have our under keel clearance and then that vertical clearance, our bridge clearance, both very important. Okay, so to calculate our tides, all of the information, even if you're using an app or a computer website or program, it's going to come from the tide tables. The tide tables get published annually. And I will click on here. Can you guys see my Chrome, or are you still on the PowerPoint?
Still on the PowerPoint.
On PowerPoint, okay. So I just clicked on that website and it brings you up to the tide tables. So for 2020, we have tide tables and current tables. 2019, the tide and current tables. So these are the historic ones, but it does have the most recent one at the top. So you do have your 2020 tide tables, and we use the West Coast. I'll go back to PowerPoint. Here we go. So there are 4 publications from, who publishes these? Is it NOAA? NOS, National Ocean Service, publishes these. So we have tide table volume 1 is going to be your Europe, Africa coast. Table 2 is your East Coast and South America. 3 is what we use, Hawaiian Islands and West Coast. And then 4 is going to be Asia, South Pacific, etc. So, so you have all of these tide tables. Oops. Gosh, okay. So, yeah, National Oceanic, I'm gonna say it wrong. National Ocean Service and NOAA publish these. So you could get them online. I think that's what I have there. So one is the tides, and this link, oh, is the actual PDF, if you just wanted to go straight to the PDF. But those are on the Google Classroom as well. So, okay. So if we open the book, we get the table of contents, and we're going to zoom in to, we have table 1, table 2, and table 3. Those are going to be our main area where we are looking at. So table 1, table 2, and table 3. There's a lot of other great information in these books. A lot of glossary information. If you are one of the Coast Guard test takers, like NavGen questions can be all found, a lot of them found in these books. There's a lot of great information, but as far as like the raw data that we're looking for, that's going to be table 1, table 2, and table 3. So we are going to dive into each of those tables, and on your handouts, it'll say at the top, or it says at the top, table 2 and table 3. The other one is table 1. It doesn't say it at the top specifically, but okay, so table 1 starts with a daily tide prediction. So that is daily, every day of the year. So it's published annually. So every day of 2019 for this specific station. So it's called a reference station. We have a tide and a height, a tide and a height, a tide and height. So it doesn't say high water or low water. It just says the time and the height. So that's when we're looking at our graph, that's when it peaks out. And then it peaks out at the bottom, and then it peaks out at the top. Those are those times that they're giving us. And then the height. And then it also gives it to us in centimeters, but we don't really care about the centimeters. we're going to go with feet. So we have a time and a feet, and that's what the table 1 gives us. So it gives us that daily information. But it gives it to us for reference stations. On the west coast of California, I didn't do the other ones. I just did California. We have 9 reference stations. So the whole west or the whole California coast, we only have 9 reference stations. So all of those little places we want to find tides in between are called substations or subordinate stations, excuse me. And that's what table 2 is. It is a list of many subordinate stations. So it is the difference, the tidal differences. So it's table 2, tidal differences from the reference station. So we have our reference station with the daily things, and then our kind of corrections, if you will, or our subordinate stations give us a big long list, so lots of detail. So for us in the San Pedro Channel, we have Newport Bay entrance, we have Balboa Pier, Santa Ana River, the Highway Bridge, Long Beach Terminal, Long Beach Inner Harbor, et cetera, et cetera. We have, I don't know, a dozen there. So it will give us more accurate tide information for specific locations, but we just have to apply this correction or this difference. So we have to apply table 2 to table 1 to get what tide we want. So yeah, tide at the reference station, plus or minus your tidal difference, and it gives you that correction, equals the tide at the subordinate station. And that's what we're looking for, the tide at our subordinate station or a specific region. That's as accurate as this book will get us, is the subordinate station. And then table 3 gives us a height of tide at any time. So if we go back to table 1 and 2, they give us just the time of high water and the time of low water, and the time of high water and the time of low water, just the time and the height. But it doesn't give us, you know, what's if the high water, I'm looking just at the first one here, high water is at 5:51, low water is at 12:56. Well, what's the tide at 8 o'clock? I know I'm not going to be out there at 5:51, but maybe I'll be out there at 8. What's the tide then? That's when we go to table 3 to find the height of tide at any time, not just the peaks or the high or the low, right? The tide at any time, we use this table. Okay, before I dive into this table, is that making sense so far? Do we have any questions on that? On kind of this tide at the reference station, apply our tidal difference, which comes from table 2, and we get what the tide is at the subordinate station.
Bree, I'm not very clear on table 3.
So now I'm going to dive into table 3.
Okay, all right.
Yes.
So is table 3 from the reference station?
So table 3, we apply our differences to get the tides at the subordinate station. So the highs and the lows at the subordinate station. And then we go into table 3.
Yeah, okay.
So table 3, the top half here is all about time. The bottom is all about the actual height. So we had those two values on our tide information. We have the time and then we have the height. Time and height, those are our 2 values. So when we look at our time, we have, so this is a zoomed in picture of the top half. We have the duration of rise and fall. So that is, how long will it take the tide to go from that low water to that high water? What is the whole time range? So there's that range of tide that goes from the high to the low. And then there's this duration of rise or fall. How long will that cycle take? Will it take your average of 6 hours? Or maybe we have a short one, it's only 4 hours. What is that duration, that total duration of rise or fall? And that's in hours and minutes. So there's a little h there and a little m there. So that indicates hours and minutes. So we want to calculate that duration in hours and minutes. Okay. Our next one is time. The other value on this chart here is time from the nearest high water or low water. So if I, had that time example of, high water was at 6 o'clock and then low water was at 12 o'clock, I wanted to know what was happening at 8 o'clock. So what is the time to the nearest high water or low water? Which one am I closest to? So am I closest to the high water or closest to the low water? And with that, what is that time? So, and that's in hours and minutes as well. Okay, so you'll kind of hear me talking about it, or you might hear somebody else talking about it. The time from the nearest tide or time from the nearest high water or low water is nicknamed TNT. So time from the nearest tide. I want to go to an example here. Let's just make one up. So let's say our range was 6 hours, right? We had a high water at 6 and a low water at noon. So let's say our duration was 6 hours and I wanted to know what the time was at 8 o'clock. So that's 2 hours from the high water, right? Low water is at 6, 12. I want to know what's happening at 8. So I go across this table. So I have 6 hours. I know I'm going to be somewhere along this line. I follow this line until I get my 2 hours. So here is my 2 hour mark. I have 2 hours, 0 minutes. So you go to whatever is closest. And you could, just guess which one's closer. This one's spot on, so that's great. So now I know I'm going to be in this column, and then we're going to go down to that bottom half of the table, but I will be in this column. And we're going to do this together, so it will make more sense for you guys. But I just wanted to do this on the PowerPoint. Oops. Okay. Okay, so then we're in the bottom half, and this is where it's in feet, or our, so the top half is all about time. The bottom half is all about feet. So on the side here, we have the range. That's going to be the total rise to fall or fall to rise, whatever it is, to high water to low water. What is the range of the consecutive tide? Whatever that range is, that's, let's call it 8. We'll have our range of 8 feet. Here's our range. Then we have our correction. Our correction, the top half of the chart tells us which column we were in. Let's say we were in this column. I'm not exactly sure. And if I had 8 feet of a tidal range, I would get a correction of 2 feet. So this is just helping us get our correction. And then that correction is applied to that nearest high water or low water that we went to earlier. And if we can't remember, we can see the note. So it says applied to the nearest high water or low water. Do I add or subtract that correction? I'm going to look down here at the bottom where it says when the nearest tide is high water, subtract the correction. When the nearest tide is a low water, add the correction. So I like to highlight that little part if you're confused, but I will be showing you my method of doing this, and it makes a little more sense doing the calculation. So stand by. Okay, highlighted that little section there. Okay, did that very fast on this?
Sorry, you were breaking up there, Bree. What did you say?
Oh, gosh. Let me move my computer a little. I'm going a little bit fast. Are you guys following along? Okay.
Yeah, I have a question if you don't mind.
Mhm.
So it doesn't look like the columns here on the correction to tide height is in regular intervals.
No, it is not a linear interpolation. That's why we have to use table 3.
That's what I was wondering. Why is that?
I don't know.
Okay, good enough.
I don't know, but we interpolate on a lot of other things, and you can just do your basic linear interpolation.
Yep.
But with tides, you can't do your basic interpolation. So you have to use table 3 to interpolate.
Got it.
Not a linear relationship.
What was that, Fred?
It's not a linear relationship.
Yes, correct. Okay, so to add one more hiccup into this, we're going to talk about time, a quick little lesson on time. So we have time zones throughout the world, right? We just had daylight savings time, 2 weeks ago now? And we are moving time zones. But every 15 degrees, so we have the world, look at the world again. And we have 12 time zones on each half of the globe, right? So if we have 180 degrees, divide that by our 12 time zones, we get 15 degrees per time zone. So at the prime meridian in England, right, we have 0. That's our base point, and that's called the prime meridian, or Zulu, Greenwich, lots of different names for that. And then we have going west, every 15 degrees changes a time zone, and going east, every 15 degrees changes a time zone. So we have 0 is our central meridian of the time zone. And it's 15 degrees on either side, or 15 degrees total. So from my 0, it's 7 degrees and 30 minutes to either side of that central meridian, that central time meridian, 7 degrees and 30 minutes to give me my 15-degree window of time, of zone description, if you will. So you can find, a little chart that has color coordinated, like the one on the bottom here, that helps you with your every 15 degrees, how it changes. A lot of times, the lines will bend by country or states to keep everyone in that area on the same time zone. Excuse me. But so us on the East Coast, no, we're on the West Coast. On the West Coast, we have the Pacific Standard Time. That is what time we hold. And from November to March, our Pacific Standard Time is -8. So our time meridian is, our central time meridian is 120 degrees west. So if we do 7 degrees and 30 minutes on one side, 7 degrees and 30 minutes on the other side, that is our central time meridian. Now, if we are in daylight savings, so if we're in the summertime, March to November, no, it's not exactly all summer, but March to November, generally speaking, we observe zone description 7, which is our daylight savings time. So if we are doing a tide, so bringing it back to tides here, our tide book has is going to be on your standard time zones. So if we are using daylight savings time, we need to put a correction on the hour for our times in our tide table book. So what we look at is that time meridian at the bottom. Okay, let me, can everyone, if everyone has their Los Angeles chart daily pages, the table 1, if you look at the very bottom, it's going to tell you the time meridian. Everyone see that?
Yeah.
Time meridian is 120. So that is for all of this Los Angeles area, our time meridian is 120. So that's the reference that I want you to double check you are using the correct zone description. I think for all of, actually no, we have an example on our homework that is during the summer, so we do a daylight savings correction. But don't get freaked out by the daylight savings correction. If you're observing, if it's summertime, you're observing daylight savings, all you do is add an hour to what's in the book, and then you're good to go. So I will show that to you on my little format sheet. But I just want you guys to be aware of it. So if you're uncertain of what zone description you're observing and what zone description you're at, the quick way to do it is to divide by 15. So if it says that we are observing, it says on the bottom time meridian 120. If we divide 120 by 15, we get 8. So we're observing zone description 8. Or that's what this is telling me. If I'm actually observing zone description 7, then I need to apply that 1 hour. So I need to hopefully know what zone description you're observing at the time. I guess some people are more aware of that than others. But anyways. Okay. Does the time make any questions on time?
So Bray, just take a example on January 1st, 2019. Okay, so the high tide was at 5:51. Okay, well, okay, I pick a wrong time. Okay, let's move to April. Okay.
Okay, there we go.
Let's do put the April. Okay, so the high tide is 6:56, April 1st.
Yes.
Right. So that's a standard time, PST. It's not a daytime.
Correct.
Daylight saving time. So in the daylight saving time, it should be 7:56.
Correct.
Okay. All right. Thank you.
Correct.
Hey, Bree.
Yes.
So with the time meridian, is that supposed to relate to the degrees of longitude?
Yes.
It is. So when I look at the San Pedro channel chart, we're sitting at the end of 117 degrees and the start of 118 degrees.
Mm-hmm.
But our time meridian is at 120.
Yes. So 120 is that central time meridian, and then 15 degrees goes on either side. So
Okay.
120 minus 7 degrees and 30 minutes, and 120 plus 7 degrees and 30 minutes. Everything in that zone is zone description 8.
Got it. Thank you. That explains my misunderstanding. Thank you.
Okay. Okay. So we are going to go to our, it's almost been an hour. Yeah. Let's take a 10-minute break. If you haven't printed these off, please print them off, or just have them on your computer so you could reference them, and get the tide calculations week 3 assignment out. We're going to do this together as a class. And then after we do that, we're going to do a quick review on calculating current, and then the rule of 12s. So we're going to do it the hard way first, and then learn the quick and short way with the rule of 12s. So grab your assignment stuff, and we'll come back at 7:30. All right, let's dive into it. Hopefully everyone has the materials, or you can just watch and I will show you where I'm getting the materials. So either way, that will work. Trying to get the best lighting on my whiteboard here. Let's see if it works. So we kind of ease into it. We're not going to do a full tide problem. We kind of ease into it on these 5 questions here. So let's practice. So for number 1, you don't like that. They ask us when and what is the AM. So I'm looking for AM low water, low tide at the Los Angeles Outer Harbor on January 26th. If the charted depth is 10 feet, what is the actual depth at low water? So we're looking for Los Angeles Harbor. Luckily, well, not luckily, this is how we're easing into it. Our Los Angeles Harbor is a reference station. So it has all of the daily high waters and low waters. So we're looking for January 26th. And I'm going to write this out so we can just see it as a group. January 26th. Okay, so on January 26th, these are the numbers that it gave us. This is the time and this is the height. So we have time and height. So it asked us, what is our AM low water? So AM, our first one here, is 0130, and this is a high water. Then we have a low water, then we have a high water, then we have a low water. So it's asking us which one is our AM low water. So that would be this answer right here. So it would be 0735 at 1.6 feet. That is going to be our Los Angeles January 26th AM low water. And then they asked if we have the charted depth of 10 feet. So we have the sounding plus the tide gives us actual depth. So our sounding was 10 feet. Our tide was a positive 1.6 feet. So our actual depth of water is going to be 11.6 feet. That makes sense?
So
Now-
B, so sounding and charted depth are synonymous.
Correct. Correct. So as an example, if we are looking on this page, Los Angeles, January, if we had if we were looking on the 23rd for our PM low water, we have a negative 1.2. Everyone see that one? So as an example, if we're in the same spot, but our tide was negative 1.2, my actual depth would be 8.8 feet because that tide is a negative number. That makes sense? Okay. Okay, let's add a step to it. Let's go to number 2. So number 2 asks us, when and what is the afternoon high tide and following low tide at Newport Bay entrance? So, and it gives us a date. Let's write this out, February 11th. Newport Bay entrance. And we're looking for the afternoon. So we are doing PM tides. What are PM tides in the afternoon on February 11th? So our Newport is a subordinate station. It is not it won't have a daily page. It won't have the daily pages outlet. So we need to apply our corrections. And this is how I like to set it up. I'm going to show you here. So I like to, or let's everyone turn to the table 2. Now in table 2, in this section right here, it says differences. High water, low water, high water, low water, and you have time and height. So I am going to find Newport entrance. It's going to be our first one there. And it has all of these numbers. So let me go back to my page here. I like to kind of make a math problem. So I have so I have my reference station, and then plus or minus apply my differences, And that gives me what's happening at my subordinate station, which will be Newport. So this is kind of my math equation. Now, how I'm going to set this table up is just like how it's set up here. We have high water, low water, high water, low water. So I'm just going to give me a high water, a low water, a high water, and a low water. This one is time, and this one is height. I could kind of do that if I want. Okay, so then I'm going to just fill in what my differences were. So I'm looking, and I'm just filling in these numbers. So for differences, for Newport, it gives me minus 0.003, minus 0.004. And this is hard to see, but that is a multiply. That is a little star, a little asterisk. So for my height, I'm going to multiply by 0.98. And for my water, or my low water, I'm going to multiply by 0.98. So here I just copied exactly what it says right here. Okay. Also on this page, what reference station am I going to be using? So I found my Newport Bay entrance. That's what I'm looking for. Then I go up. I follow my finger here, and I go up until it tells me in bold which reference station to use. So this says use the Los Angeles on page 76. So it even tells me flip back to page 76 and use Los Angeles as your daily tide table, or your table 1. So if you were using any of these, you're going to be using San Diego as your reference station. So you always go up there. So we're going to use Los Angeles. And we are looking for February 11th. So I'm looking on my page 76, and I usually like to write this. My reference station was Los Angeles, page 76, just in case I have to flip back to that page. So I'm looking for February 11th. I'll write out here, just so we could see it. 0107, 4.2. Okay. So it's asking me, what are my PM tides? So I'm going to be looking at my PM tides. These are in AM, and these are in PM. So I'm going to be applying my corrections from my reference station, applying my differences to get what's happening at Newport to these PM tides. So in order to plug it into my little table here, I need to know which one's high water and which one's low water. So I can see from here that my 1310 is high water, my 1853 is low water. So I'm going to transfer these numbers into my table up here. So I have 1310 at 3 feet is going to be my high water. My low water is 1853 at 1.6. So I just transferred these numbers from my table 1 to my table here. Following so far? Okay. So now I apply those differences. So I just go down for each one. So 1310 minus 3 minutes gives me 1307. 1853 minus 4 minutes gives me 1849. 3 times 0.98 gives me 2.94. And 1.6 times 0.98 gives me 1.57. So now I can say at Newport on February 11th in Newport, 1307, the tide will be 2.9 feet. And at 1849, the tide will be 1. I'll call that 5 feet. So if we look at this, it is very, very close. These corrections are very, very small, right? To the reference station. So when you see at, at West Marine or OCC bookstore, if we were having class, I'd hand them out those little tide books that are kind of like the pocket book, little tide tables. Those are your table 1, your Los Angeles Harbor tide tables printed out in little pocketbook form. So because in Newport and a lot of the places that we are navigating, this correction is so small, we can just use the reference station and say, hey, that's good enough for me. I want a wiggle room anyways. Don't want to bother with calculating the difference at the subordinate station. But if you are navigating someplace else, say the Puget Sound or San Francisco, then you're going to have a much bigger difference from your reference station. So you'll definitely want to know, like if you're navigating somewhere, look at those differences at your reference stations and say, is it worth me doing this calculation, or can I just use table 1, use that reference station? Does that make sense? Okay. So this was number 2. So we had to apply our difference. So we applied, this was table 2. This is table 1. So we applied table 1 and table 2, and we got what was happening in Newport. We still don't know from this what's happening at a specific time. What's happening at, 1600. I know I'm going to be getting off. What's happening at 1600? I don't know yet.
Bree, you froze again.
There she is. She's back.
I'm back.
Yeah, you froze there a little while ago.
Okay. I'm getting closer and closer to the door here.
Rick, just follow up on your early comments about is that worthwhile to make to do the adjustments. So can I do this? If I look at the same page of table 2, and on the very top one, Guatemala, all right? And over there, the factor is 0.61, which is very significant, right? So some area, some areas like that, I'll say I'll use the correction.
Correct.
But on the Newport Beach is 0.98, very close to 1. I just ignore it.
Yes.
Okay.
Yes. And let me just show you here on the corrections.
And some of that is not a factor. Some of them are minus 0.1.
Yes.
Is that just a minus plus?
Yes, it's either minus, plus, or a factor.
I see.
So if we are looking at San Francisco Bay,
Yeah.
we have lots of subordinate stations within San Francisco Bay. We have, oops, get zoomed in on this. We have time differences of up to an hour, 54 minutes, an hour, 23 minutes. Focus that for you. So those time differences are going to be significant. 0.18, 1.36. So depending on, how, it also depends on how close you are to that reference station is how big your difference is going to be as well. Are you pretty far? What is the, topography of the sea floor, and how is that affecting your tide as well? If we go up to Puget Sound, they have some, there we go, some bigger differences. There's a lot of factors on here, but yeah, bigger differences in time and in factors.
Yeah.
So for us in Los Angeles area, it's pretty minimal. But maybe you're not sailing in Los Angeles, you want to know how to do it. So, but if you think it's too complicated and you just use the little pocket guide, that's fine for sailing in Newport. Okay, so let's do number 3. Okay, number 3, we're actually going to, oh no, we're not. Let's just do number 3. Okay, you're cleaning up after the Christmas boat parade in Huntington Harbor. Your boat needs extra room to clear one of the bridges. When and what are the evening tides on December 26th in Los Patos? Excuse me. So we are looking at December 26th. Los Patos. And we are looking at the PM tides. So similar question to what we just did. We're just going to get what the PM tides are at this subordinate station. So we'll look for that subordinate station. It is number 433. So I like to write that sometimes. And I'm going to make my table. Okay. So for my differences, I'm just going to go to Los Patos Highway Bridge. And we have a little bit more of a difference here. Oh, you guys maybe see it. Let's write it in. Crap. Okay, so I have my differences written in, and then I look up and see my reference station is Los Angeles, page 76. So I go to my table 1 for Los Angeles, and then I flip over to my December 26th. December 26th, I have so I have these numbers for our December 26th. And they are asking us what our PM tides are. So again, we're just going to be looking at our PM tides. In order to transfer it to our table here, I need to know which one's high and which one's low. So in this case, our first one, our earlier one, is low water, and our later one is high water. So then we plug it in. So we have our low water is 1547 at negative 1.2. So I put that in the low water column. And then I have my high water. I'm going to put it in the high water column. 2220 at 4.0. So make sure it's coordinated with our high water and low waters. Then I apply my corrections to get what's happening at Los Patos, what's happening in the Huntington Harbor. So here I have 2320. We always do our minutes first. So we have 9, 5, 16. And then we have 4 times 0.83. It's going to give us 3.32. And our negative 1.2 times 0.6 gives me a negative 0.72. So now I always like to write it out chronologically, just so I can do the next step easily. So I have in Huntington Harbor, / Los Patos at 1659, I have negative 0.72. At 2320, I have a 3.32 tide. So these are the tides I'm looking at. So in Los Angeles, it was a much bigger range. We have a little bit of a smaller range in the harbor. And it's happening much later for us. So Good to know. Oh, okay. Is this making sense so far? So this one we had a much bigger differences, but it all depends on what your subordinate station is. So we applied our reference station, we got a reference station, applied our differences to get what's going on at that subordinate station. And then we could just write it out. Okay. Let's do another one. Okay, we are planning a trip to Avalon this weekend. You need to make sure you have enough scope on your anchor chain. When and what are the AM low water and the PM high water in Avalon on March 28th, 2019? We're looking at Avalon. We want the AM low water and the PM high water. Okay. Oops, put this down a little bit. So Avalon is a subordinate station. Which station number is it? Oh, there we go. It's 469. So it's down under Channel Islands is our Avalon. So I'm going to make my table. Okay, so my differences for Avalon are going to be plus, always use that wrong one. Plus 0.006 plus 0.009 multiply 0.96 and multiply 0.96. So I just copied those on the Avalon differences on table 2. And then I follow my finger all the way up and see my reference station is Los Angeles. So I go to Los Angeles tables for my table 1. And I am looking at March. So I have March 28th. And this is going to be a daylight savings one, but let's just put our numbers in first before I get ahead of myself. Okay, so March 28th, we have 02, 52, 4.2, 10, 50, 0.4, 18, 17, 3.4, and 22, 41, at 2.8. And that's March 28th. Okay, so they wanted to know my AM low water and my PM high water. So they want these guys. So I'm going to be there in the middle of the day, it looks like. So I want to know what the tides are for that middle of the day range, right? That rise or fall right at the middle of the day there. So I'll get these numbers in. So my 1050 is low water and my 1817 is high water. So I'll write these in. 1050 is my low water. So I have 1050 at 0.4. Then I have my high water, 1817 at 3.4. And that's what I have for my reference station. So I'm going to erase this guy. And now I'm going to apply my numbers. So I have 1817 plus my 6 minutes gives me 1823. 1059. 3.4 multiplied by 9.6. So now let's add our daylight savings time. Because this is March, we have our daylight savings time. So we are going to add an hour. So I get 1923 and 11:59 for my tides, the time of my tides. So when I write this out, I have Avalon, March 23rd, 11:59. The tide is, put it a little bit closer, 0.4. And then at 1923, the tide is 3.3. And those are my tides for Avalon. So with daylight savings, we just added an hour. Okay. Let's do another one. So our next one, we're gonna go to table 3. Does anyone have questions on using table 1 and table 2? Okay, so now we're gonna move to, we do everything we do, table 1 and table 2, and then we also use table 3. So let's dive into that. So number 5. Oh. Okay, this one, we're planning a Valentine's Day cruise with your sweetheart. We are adding information to our voyage plan and our DRs. What is the tide at 9:55 on February 14th in the Los Angeles harbor? So we want February 14th at 09:55 at LA. So our Los Angeles Harbor is a reference station. We don't have to do our corrections. So lucky us, let's see what the tides are on February 14th. Okay. So I'm just going to put it down here. We have 04, 12, 5.0. So here, when we're looking for a specific time, I like to, I call it sandwich or kind of bracket that time that we're looking for. So which two tides, where's my rise and fall gonna fit in for my 9:55? So in this case, my 9:55 is gonna fall in between these times. So those are the times I'm going to write in my table that I'm going to show you here as my times. So I'm going to have 04, it's basically writing it again, 04:12, the tide is 5 feet. At 11:56, the tide is 0.2 feet. So when we go to our table 3, we have these, oh, I didn't write in. I want to know what's going on at 9:55. What is the tide? So from looking at this, I know it's going to be somewhere in between 5 feet and 0.2 feet. Because I know at 4:12, it was 5 feet, and then it's falling, it's getting, lower and lower and lower and lower until it gets to 0.2 feet, and then it's going to get higher and higher and higher again. So at 9:55, it's going to be less than 5 feet, but I don't know by how much. So I need to do a little bit of calculations. So if I look at the difference between my high water time and my low water time, that is called the duration of rise or fall. So this is going to be the duration of fall. How long did it take to go from high water to low water? So we're going to calculate that out. So 12, I get 4, 4, and 7. Yes. So I got 7 hours and 44 minutes for my duration. Over here, I have range. So that's the range in feet. How much did it fall or how much did it rise? So my range is going to be the difference here. So my range fell 4.8 feet. It went from 5 to 0.2. It fell 4.8 feet. My next step is to do that TNT, time to the nearest. So is my 9:55 closer to 4:12 or is it closer to 11:56? Yes, it's closer to our 11:56. That's going to be our TNT, time to the nearest tide. So I'm going to get the difference between these. I get 1 minute and 2 hours. Yeah. So I get 2 hours and 1 minute. And then I have my little bracket down here. So I'm going to have my other little bracket there. And that, I'm just going to make this 01. There we go. This little bracket here is going to be called my correction to tide. So when we look at table 3, let's flip to table 3. We have our duration of rise and fall. We have our time to the nearest. We have our range. And then we have our correction to height. So those 4 things we have right here. And we need to find the missing piece so we can get what our question mark is. So let's navigate this table. Zoom in a little bit here. Okay, so our duration was 7 hours and 44 minutes. So I'm going to go to our closest one, which is going to be 7 hours and 40 minutes. And then my time to the nearest was 2 hours and 1 minute. So I'm just going to go across until I find 2 hours and 1 minute. So I found 2 hours and 3 minutes. Close enough. So I just circled it there. But that is telling me that I'm going to be in this column. I'm going to be somewhere in this column on the lower half of my page. So now I can go in with my range, which was 4.8. So I'm going to find where's my range of 4.8. We have closest to 5, so I'll just use 5. And I have a correction of 0.8. You see how I found that 0.8? So I followed this guy across to find which column to use, and then I found which range to use, and I stayed in the same column. So my correction is 0.8. Now, do I add or subtract that 0.8? I know that I have to be in between my 5 and my 0.2. So I have, if I subtract it, I'm going to go below my 0.2. So I'm going to add it. So I get, 0.2 plus 0.8 gives me 1.0. So I have a tide of 1.0 at 9:55.
How do you know that you don't make the correction to what was our high water of 5 feet?
Because we did time to the nearest. Whichever one you applied to on your time, you're going to apply to on your height.
Okay.
So our nearest one here was to the low water, so we apply it to the low water here. Sometimes when you're calculating you have different missing values. Say you're looking for when is the tide going to be, when is the tide going to be 2 feet? And that's what you know. So you're looking for a correction of, 1.8. But you know that 2 is closer to 0.2 than closer to 5. So it's whatever is closer is the one that you're applying it to. So you could work this, table 3 anyway.
So Bree, for this question then, is after you've gotten this 1 foot difference, do you then go back to table 1?
Nope, that is your tide. So to clean this up, I'll just erase these guys. So the question, the question was asking us, what is the tide in Los Angeles at 9:55 on February 14th? So at 4:12, it was 5 feet, and 9:55, it's 1 foot, and at 11:56, it's 0.2. So we found out what the tide is going to be. So we could apply that 1 foot tide to all of our soundings at 9:55. And then we also can know that it is a falling tide. So a little bit earlier than that, if we go, 9:45, tide's probably going to be more than 1 foot. If we call it 10 o'clock, tide might be a little bit less than 1 foot. It's a falling tide.
Okay, thank you.
Okay. Now we have a bonus question. I don't know why it's just not. Oh, we have a bonus question and question number 6. Okay. That's fun. I'm gonna erase this. Okay. After a 2-day cruise, you are returning mid-morning and looking for low tide to clear a bridge. On February 16th, when is the AM tide less than 1 foot? Does it give us a place? I guess this is a continuation of LA. It's February, I guess it is 2 days later. Okay. And we're in LA. So making it easy on us. We don't have to do our table 2 corrections. So on February 16th, let's get the numbers for February 16th. Okay, there we go. So we want to know when is the tide, all right, we're looking for a time. When is the tide going to be 1 foot or less in the morning on February 16th. So on February 16th, we have a high tide at 06:08, and then we have a low tide at 13:26. So it is a falling tide. So when is it going to be less than 1 foot? So I'm going to use these guys as my sandwich or my bracket. And I'm just going to put it up here. And I want it 1 tide. That's what I want. And then I have a low tide at 13:26 of negative 1.1. And my question is, what is the time that that 1 foot will be happening? So I kind of just touched on this before. I didn't know we were going to do it. So we want to do the same thing on our bracket here. We want to know the duration. We want to know the range. And then we want to know to the nearest. So I have 6 and I have negative 1.1 and I'm looking for the 1. So is my 1 foot closer to high water or low water?
Low water.
Low water. So that is where I'm going to be getting my TNT and my correction. Okay. So let's calculate these numbers. For duration, $13.26 minus 0608. 6, so that gives us 18. Yeah. And 13 gives us 7. So we have 7 hours, 18 minutes. Our range, so on our range, we have a high water of 6. So our, let's see, our graph goes up to 6 feet, and then it goes down all the way to a negative 1.1 and a 6 foot. So what was the difference here? It passed 0. So our difference or our range is going to be 7.1. So it was the 6 and the 1.1 going down into that negative on our number line, if you will. So our range is 7.1. Now for our correction, how do we get from negative 1.1 to a positive 2? What is the correction that we need?
2.1.
2.1. That's the correction that we're looking for. So we have 3 of our 4 numbers. So now we can use table 3 to find our TNT. So let's go to table 3. Okay. I don't have an eraser. Okay. So the 2 things that we know are going to be on our feet side. The thing that we're missing is on the time side. So when we go to our table, we're going to start with the 2 things that we know on the feet section and then move our way up to the time section. So we know our range was 7.1. So we're going to find about 7.0 was our range. And then I'm looking for a correction of 2.1. So I'm going to move across the side or this line until I find 2.1. So here is 2.1. And that means I'm going to be in this column. So I'm going to stay in that column. And the other piece of information I know is my duration. My duration was 7 hours and 18 minutes. So if I find 7 hours and 20 minutes, that's going to be our closest. So I bring over my 7 hours and 20 minutes. Let me try to get it lined up here for you. And see where that meets on my column. So I have a correction of 2 hours and 41 minutes.
Is that a correction or is it just a time?
That's in hours and minutes, 2 hours and 41 minutes.
Oh, okay, yeah.
So we have that H and the M up there.
That's a TNT.
And that's our TNT.
Yeah.
So we have 2 hours and 41 minutes. So now we apply that 2 hours and 41 minutes to our 1326, 2 hours and 41 minutes. Are we going to be adding or subtracting these 2 hours and 41 minutes?
Subtracting.
Subtracting. We have to stay within this bracket or this sandwich here. So it's in between 6 and 1326. So we have to subtract this 2 hours and 4 minutes. So in order to subtract, we can't subtract 26 from 41, so we borrow. 86 minus 41 gives us 45 and 10. So our time is going to be 10:45, that our tide will be 1 foot. So that I can, if I need at least, I would need at max 1 foot tide, because I need to make a lot of clearance under this bridge, I can go anytime after 10:45, because it is going to be less than 1 foot. It'll be shallower after 10:45. So 10:45 is the earliest time I could make that crossing of the bridge. Okay.
Could you just show me, if you don't mind, my head was down when I was running a calculation. How did you get the correction? Where did you get the correction value, the 2.1?
Yes, so that is going from 1.1, how do I get to a positive 0.1? So you're getting the difference here, and you're subtracting a negative, which if you're looking at math equals adding, or if you're looking at a timeline here, right? I think that was easier. So if we had 0, here was our negative 1.1, and we want to get to a positive 1. What is the difference? What is the correction that I have to get to that tide? So we have 1.1 and 1 to get a correction of 2.1.
Okay, thank you.
Okay. How are you guys feeling? Do you want to take a quick break? Trying to do more breaks for everyone. And then jump into one where we have a table 1, 2, and 3? Or should we dive into a big one?
Go for it.
Okay, let's do it.
Hey, Bree, I have a question. Is this all going to be up on your, maybe we can we refer to this video later? Because I'm kind of fading in and out.
Yes, yes, you can.
Okay, thank you.
Okay. Number 5. That one doesn't work. Number 5. We are starting off the year fishing at the Santa Ana River entrance. What is the tide on January 1st at 07:20 at the Santa Ana River entrance? So our Santa Ana River is a reference station. So if we look at our reference stations, Santa Ana River is number 431. Okay. So on this one, we go all the way through our table 1 and 2, and then we move to table 3 because we have a specific time that we're looking for. So my first step is to find what's happening at Santa Ana River. What are the highs and lows? So let's make my table. Okay, so I'm going to copy in my differences. Nope. What are my differences? Okay. Santa Ana River differences. I have plus 0 hours, 23 minutes, plus 1 hour, 47 minutes, multiply by 0.54, and multiply 0.2. Let you guys copy those. All right, so I just copied my Santa Ana River, and then I go up and I see my reference station is Los Angeles, page 76. So what's happening at Los Angeles? On January 1st. So I'm just gonna write in here so we can use it as a reference. 0551 was 5.8, 1256, 0.0, and 1907, 3.6. So this is January 1st for LA. And I'm looking for a time of, I'm looking for a time of 7:20. So I want to know on here, which of these will sandwich my 7:20 that I'm looking for. So I can see that these guys here are going to sandwich my 720. So these are the numbers that I'll use for my high and low. So this one is my high water and this one is my low water. So I'm going to put in for my high water 0551 at 5.8. Then I'll put in my low water 1256 at 0.0. So I have what's going on at my reference station, and I need to see what's going on at Santa Ana. So now I apply these corrections. I have 23 minutes, 70, that gives me a 1, carry 1, gives me 6, 0614.
Yeah.
4, yeah, 1 gives me 14. Then I need to multiply. So I have here what's happening at Santa Ana. And now I'm going to rewrite it so it's chronological and I could do my brackets for table 3. So at Santa Ana, I have 0614. My tide is 3.1. And then I have at 1443, my tide is 0. I want to know what is the tide at 720. That is my question. So this is where we go to table 3. Okay, so on table 3, we need to figure out where our 4 pieces are, or brackets. So we have duration, we have range, and then we have time to the nearest. So is my 720 closer to my high water or my low water?
High water.
High water. So here is my time to the nearest. So here is where my correction is.
Yep.
Now let's take a minute and get what these values are. This is going to be our missing value, but we're going to have our other values. So we have So go ahead and look at your table 3 and tell me what correction you guys come up with.
0.1.
0.1. Are we going to add or subtract that?
Subtract.
Subtract. So we get a tide of 3.0 at 7:20. So here I can see my my duration is 8.5 hours, and I only have my time to the nearest is only about 1 hour. And with my range of being 3 feet, I can kind of see that I'll probably be pretty close to where that high water is. It hasn't fallen that much. Remember, in the middle, those middle times, so half this, around 10 o'clock is where you're going to get that faster fall. You're going to get more of a difference. I think I'm overthinking it for you guys, but if we look at this on our graph form, change the color, we have sorry. If we are looking at a time that's very close to one of these, it's not going to be a huge difference. Remember, our middle times is where we're going to get that bigger difference. So I guess that's why you're not doing your linear interpolation.
Right.
Yeah, that kind of makes sense, but it also seems like we could create a function that will describe it too.
Maybe that's what the websites do. I don't know.
Yeah, I'd have to look into it.
Okay. Let's take a 10-minute break here. Let's come back at 9:05, and we're going to go back to our PowerPoint, where we're going to touch on current and then do the short and easy way of calculating tide instead of all of these tables and steps. Okay. All right. So before we dive back into the PowerPoint, I did want to show you guys on the Google Classroom, and I emailed you, Tim. I have posted some extra problems. So under assignments, you had the week 3 calculations, which we just did in class. That's assignment 3. And then I have extra tide and current problems. So these are those Coast Guard questions. So just a ton of tide and current calculation problems, but they are not referencing the 2019 West Coast tide table. They're referencing the 1983 East Coast tide table book. So there is the PDF if you want to do more practice tide and current questions. We're going to go over currents shortly here. But to do more calculations, you guys can look at those. And then I also wanted to show you down in reference materials, I have Bree's step-by-step guide to the tide problem. So if you forget what I was saying, or you wanted a little I don't know, guide or reference to my little table that I make. This is your step-by-step guide of how I do tide calculations. Now, if you take this class from another instructor, ask another instructor how to do a tide question, they might do it a little bit differently. I feel like every place I've taught at teaches it a little bit differently. This is what makes sense for me. So, I mean, it's all basically the same. Another instructor is not going to do it differently, but what I'm saying is different is kind of my little table that I set up. A lot of other instructors kind of set it up on on that line graph, right? That that curve, and kind of try to do the calculations that way. If that makes more sense to you, I'm sure there's a bunch of YouTube videos out there if you want to check those out. But this is my Breeze step-by-step calculation. And then I have the links to your tide tables, your assignment 3. I think that's all I wanted to show you. So yeah, that was my little guide. And then if you want to do more practice problems, check out the extra tide and current problems.
Bree,
Okay.
How long are you going to keep this classroom active?
So I keep you guys on it until we have another CoNav2.
Okay. Right.
And then I'll take you guys off and put another one on. Now, Fred, I did ask my boss about giving you access to other classrooms and how long we could keep people on it. So my I guess intent of making it is to just leave you guys on it, like I don't really care. But she's having a meeting with another higher up person to discuss the privacy, copyright, whatevers of the class. The actual college uses, instead of Google Classroom, they use a thing called Canvas. I think a lot of actual elementary schools and high schools and stuff use that now, but it might be changing. I guess long story short is they might be telling me I can't use Google Classroom anymore. I don't know. I don't know what they're going to come up with. So I will keep you posted if I find out, but my intention is to just leave you on here until we get another CoNav2, which is happening in March. So you'd be on for a couple months.
Okay. Thank you. Okay.
So I'll stop that. Okay, let's go back to the PowerPoint. Let's wait. Any big questions before we dive into the PowerPoint?
I have a small question, Bree, on the table 1.
Yes.
On some days there are circles or half circles and solid dots. I assume they are indicating the moon, right?
That's correct.
Okay, right.
Yes.
Thank you.
Okay. Okay. Why is that so weird? Okay, so we are going to dive into calculating currents. This is just going to be a quick review of our tables. I'm not going to do an actual calculation, but I do have a video of myself doing an actual calculation, so you can check that out. But let's dive into it. Okay, so on kind of similar to our table 1 or our daily pages, we have daily pages in the current book. So for each day, we have a time of slack and then a time for maximum. So this is saying at 3:14, the current was slack. And then at 6:18, it reached a maximum of 1.7 knots flood. That F is for flood. And then we have, it went to slack at 7:15, and then at 12:12, we were ebbing. And then we slacked and then flooded, and then slacked and then ebbed. Oops. So to follow this timeline, we kind of do this across and then down and zigzag, across and then down and zigzag. And those maximums, to find what their value is, the value of that maximum current, the velocity, is going to be in knots there. So we have our slack column in hours and minutes. That's the time. And then we have our maximum. So that's that maximum flood or ebb with the knots there. So it's similar to the tides, but it is set up a little bit differently because we don't have high water, low water, high water, low water. We have slack and then an ebb or flood, and then slack and then an ebb or flood. So it looks similar, but it's a little bit different. And then up here at the top of the page, we'd have the average for the area. So for San Diego Bay, your average flood is 355, your average ebb is 175. So you have a direction there. So your current has a velocity, your drift, and then your set is your direction. So same type of thing for reference station and subordinate stations. This, right in this example here, our reference station is San Diego Bay. Now we have our table 2 with all of our subordinate stations. So we have many, many, many subordinate stations. If we zoom in on it here, so here's subordinate stations. They give us a position, so it's always good to know that. And then in our time differences, they have minimum before flood, minimum before ebb, and ebb. So that minimum before flood means slack. So that's, when is it going to be as close to zero as possible? When is it going to be the minimum amount of velocity? So that's your slack. That's just a fancy way of saying slack. So your slack, your flood, your slack, your flood. And then right here, you have your speed ratios. So this is going to be that correction to the velocity, to that speed. And that's going to be a ratio where we're going to multiply it. So there's not going to be any adding or subtracting. We're going to multiply. So we have our time differences, our speed ratios, and then for our subordinate stations, that direction of the current might be different than the actual reference station. So we're going to look at our average maximum floods and ebbs for our direction to figure out which direction it is at our subordinate station. Okay. Okay, so any questions on that? On our table 1 and 2 of the current book? It's similar but different to the tide table. Okay.
Hey, Bree.
Yes?
So the speed ratio should be multiplied by the drift?
Yes.
Okay. Just making sure I noted that properly. Thank you.
Yep. So then we also have our table 3, which is going to give us our current at any given time. So our table 1 and 2 gives us that slack and that maximum. But what if we want to know what the current is at a specific time? Or what do we, if we want to know the current, a certain number, when is it going to be that number? So we use this table 3. Now it says here, table A, that's just because it's divided in half to table A and B. I don't know if you can see it. So it is table 3, but it has an A and a B section. Okay, so our on the side is our interval between slack and desired time, and that's in hours and minutes. Oops. So that's similar to that duration, right? What is the interval between slack, or no, this is slack and desired time, excuse me. Let me go to this one. Interval between slack and maximum current. So that's the time interval between the slack and the maximum current. That's going to be similar to our duration, right? That's the bigger one. And then we have the smaller one, which is the interval between slack and desired time. Now here, we don't have that TNT. It's not nearest. It's always slack. So this is just reference to our table 3. We had our TNT at the top and our duration on the side. So it's kind of flipped for our table A. We have our TNT on the side and our duration on top. Duration up here. And this is, instead of TNT, it's time to the slack. Slack to our desired time. So we always go from slack. And then the top is going to be our duration. So we use those 2 times, and wherever those meet gives us a factor. They call it a factor with a little f. So that's going to be our factor, whatever time we get. Or we use these 2 times and we get our factor. Now, if we look at the bottom, it tells us to multiply the maximum velocity by this factor. So if I go back to this one, our TNT, or our time to desired, the desired time goes to slack, but the factor goes to the maximum. So the factor is going to that maximum number, where our time interval goes to that minimum, that slack number. So it can be confusing. But as you practice it, it'll get better. So this is, and then, oops, also I wanted to note why there's table A and table B. So for table A, used for all places for those except for those enlisted B. Table B, they list these guys. So that's why
I got it, Bree.
That's why
I got it. It's exactly the same as the current table, but different. And then TNT is close to the, and it's all fact up. Got it.
Cool. Okay, so this is kind of my final little table, but as you can see, it's very similar to my tide table. So I have my reference station, my correction, and then what it's going to be at the New London Harbor. So I just copy what it says on the differences. It said MBF, flood, MBE, ebb, which is essentially your slack, your max, your slack, your max. And then right next to it, you have your speed ratios for your flood and your ebb. So I just copy all that down on the correction side. And then I go to the table 1 to figure out what I have on my number, or my, bigger side, and then just apply those corrections. So very similar to tides. And then I do kind of the same setup here with my brackets. I have my I set what information I found here chronologically. So I found that at 1437, I had a slack water. At 1901, I had a maximum ebb of 0.4. So I have to find my interval between slack and max, my interval between slack and desired time, and then I get a factor, and I multiply that factor by my maximum ebb to get me my current at the desired time. So I know I went through this very quickly, but I do have the YouTube video there of me walking you through it. So this is number 1 on the, I'm pretty sure it's number 1 on the Murphy or the Lapware extra problems. If you're doing the extra problems. So, and again, the extra problems are referencing that 1983 tables. Okay. Oh, okay. So your Lapware and your Coast Guard training questions reference the 1983. Okay. Any questions on, I'm sure there's a million questions. Does anybody want to say anything about the currents before I move on back to tides?
Yeah, Bree, the slack means, slack really means that no horizontal movement of the water, right?
Yeah, no horizontal movement.
Okay, so is that a point of time or is that a period of time?
It is, so in this table, it's a exact time, but it is really a period of time. So let me show you on in the book here. You can, what they have is the duration of slack. So you kind of had this window of time of when is that tide or that slack going to be less than 0.2 or 0.1. Let's show you here. So this is the duration of slack table that you could figure out the period of time when the slack is not more than 0.1, 0.2, 0.3, up to 0.5.
Right.
So if that maximum current is, 5 knots, and you're looking for your 0.3, you have a 14-minute window. So whatever time you got from the tables 1 and 2, you add, 7 and subtract 7. So you have this 14-minute window when your current is going to be less than 0.3.
Okay, so that time is the middle of this duration.
Correct.
Okay, all right.
Correct. Okay. Okay. Oh my gosh. We're almost out of time. I am sorry. We're going to do this rule of 12 real quick. Yikes, I spent too much time on that. Okay. Rule of 12s. So rule of 12s is what a lot of people like to say, oh, I don't do tide calculations. I just do the 12ths and it makes more sense for me. That is great for the rule of 12s is based on the semi-diurnal tide, where you have 2 high waters and 2 low waters throughout the 24-hour hours of the day. So they're really 6 hours apart and they're even. California doesn't have that. California has this mixed tides. So this is what California looks like, and this is what everywhere else around the world. Not everywhere, but the majority of the world has semi-diurnal tides. Okay, so if we are looking at this perfect semi-diurnal graph. And we have from high water to low water, 12 hours or 6 hours, right? Because it's 6 hours per, there's 2 per day, or I'm getting my numbers wrong. There's 4 tide changes, 24 hours in a day. So each tide change has 6 hours. So we divide up exactly 6 hours. And on this 6-hour division, in the first hour, the tide only changes about 1/12. In the second hour, it changes about 2/12. In the third hour, about 3/12. Fourth hour, 3/12. So right in that middle is where you're getting more of that change, a lot of change happening. And then it kind of slows down with the changing 2/12 back to 1/12, and then it goes the other way. So we have this 1, 2, 3, 3, 2, 1 kind of pattern if we have our 12ths per hour. So we're going to keep that pattern in mind. 1, 2, 3, 3, 2, 1. So the rule of 12s is that we apply those 12th numbers to quickly calculate what the tide change will be at each hour. So let's do an example real quick here. So we have a low water at 0300 at 2 feet. We have a high water at 900 at 8 feet. What will the tide change be at each hour? Excuse me. So our range, that's going to be the difference between high water and low water, the total amount that this water is going to rise is going to be 6 feet. So that 6 feet I divide by 12. So the 12th is that total change, is that range. So you're dividing the range by 12 and getting a value. So in this case, our value for 1, 0.5, our value for 2/12, 1, 3/12, 1.5. So that's our how our tide is going to change by the hour. So let's put it into a little table. So we know at 0300 it was 2 feet, and it's going to be rising till 0900 at 8 feet. And it's going to be changing in that 1, 2, 3, 3, 2, 1 pattern. So I like to put next to it what those numbers actually mean. So from 2 feet, it's going to change 1/12, which is 0.5. So at 4 o'clock, it's going to be 2.5. Then I'm going to change by 2/12. So I'm going to add an out 1 foot, and I get 3.5. Then, oops, I clicked it too soon. Then from my 5 o'clock to my 6 o'clock, it's going to change by 3/12. That's 1.5. So I'll add 1.5 and I get my 5. The next hour, it's also going to change by 3/12. Add another 1.5. Then I'm going to add my 2/12 for the next hour. So I add my 1. And then the next hour, it's going to change by 1/12, just 0.5. And I get my 8. So that's just a quick way to see what the tide is doing at each hour. If you can quickly in your head divide the range by 12 and then see what it's doing. Okay, let's do an example of a rule of 12 real quick. I think it'll make more sense. If we go back to our assignment 3. I know I'm going a little bit over here on time, but I just want to finish this.
So Rule 12 does not apply to California, right?
Yes.
Okay.
Because our tides are not exactly 6 hours apart from one another.
Makes sense.
Okay, so here it is. Our tide calculations. Oops. Number 7, using the rule of 12s. It says, after looking up your tide information, you see that at 0900, you have a tide of 3 feet. At 1500, you have a tide of 7 feet. We have a sounding charted depth of an obstruction of 3 feet. In order to safely pass this area, you need 7 feet of water. Using the rule of 12ths, what is the earliest time you can make a safe passage? Okay, so under keel clearance, or it's not necessarily under keel clearance, 7 feet. We're going to get to that section later. Let's just do our rule of 12s for this information. So our time and our height. So my first step is to figure out my range. So my range, what is my range going to be here? 4. Let's get a better marker here. So my range is going to be 4 feet. How do these markers work? Okay. My range is going to be 4 feet. So now I want to figure out what 1/12, 2/12, and 3/12 of my 4 feet are. So 1/12 of my 4 feet is going to give me 0.333. 2/12 is going to give me 0.666. And 3/12 is going to give me 1.99991. So I have my values for my 3s. So now I'm going to put in a little timeline here. So I have 0900, 1000, 11, 12, 13, 14, 15. So at 0900, my tide was 3 feet. My change is going to be 1, 2, oh gosh, I'm not going to line this up right. 1, 2, 3, 3, 2, 1. That's my pattern. So my 1 is going to be 0.33. My 2 is 0.66. 1, 1, 0.66, 0.33. Oops, not on the page. So let's put in our numbers. So from 3 to 1 to the next hour, it's going to change 1/12. So I'm going to get 3.3 as my tide. Then I'm going to change 2/12. So that's adding a 0.66. So that's going to give me an even 4.0. Then I'm going to apply my 3/12. So my 3/12 is 1. So then I get 5.0. I do another 3/12, which is 1. So I get 6.0. Then I do my 2/12. So that's the 0.66. So I get 6.66. And then I apply my 1/12, which is 3.33. And I get my 7.0, which checks out. So I kind of have a tide table an hourly tide table of what my tide is doing by the hour. So then I'm going to go back to the question here. So our question was, we have a obstruction with a sounding of 3 feet. So let's erase this. We have a sounding of 3 feet. We need
7 feet.
7 feet of water. So what I need to happen is for the water to be 7 feet. So what does my tide need to be?
4 feet at minimum.
Minimum of 4 feet. 4 feet or higher. So the earliest time that I can make safe passage would be my 11 o'clock. Anytime after 11 o'clock, I'll have more water. So if I was just doing the rule of 12ths in my head and I didn't do this whole tide table thing, I see that I have 1/12, or I have, you know, my tide of my range of 4. Divide that by 12ths. I guess how it goes. I don't know.
It's a third. So
It's third. Yeah, it makes sense in my head, but I can't explain it. I'm having trouble explaining this one, but I hope it's making sense.
Yeah. So Bray, on the this question, the time difference happened to be 6 hours. Okay, in different situations that might not be the case, but you need to divide it a time by 6, right? Divide the time duration by 6.
We divided it by 12ths. So this whole rule of 12ths works if your duration between rise and fall is 6 hours. That's why the rule of 12ths works. Okay. But if you don't have that 6 hours, the rule of 12 doesn't really work.
Okay. Well, what I mean, you should divide the range of change by 12. The range of the tide.
The 4?
12, but the time differences, the time duration, you should divide it by 6. Is that correct?
That is 6 hours.
Yeah, but you know, for instance, if you you know, if your information given to you was not exactly for 6 hours, right, between the high tide and low tide, it's not exactly 6 hours. It's oh, okay, well, all right, I got you. Yeah, that got back to the point. Yeah, back to the point. The point you said the most of the world is have a 6 hour interval.
Yes. Yeah.
Okay. Got it.
Okay. That's all I got. Sorry for keeping you guys a little bit later today. Next week, there is the final plot. So the final plot kind of touches, kind of like CoNav2. We touch on a little bit of everything we did with a chart plot exercise. So we'll go over that. Oh, actually, cancel that. There is some questions on that final plot, but the final plot, I don't have it on me right now, but the final plot is kind of this 3-day voyage, or this voyage from Newport down to Catalina and back up to LA, kind of like we've been doing. But you guys are doing a full voyage plan. So it's a voyage plan, and you could decide if you're on a sailboat or you're on a power boat, what speed you're going to use. and to create a voyage plan of what's my course and speed. I have this set in drift, so how do I need to change my course to steer for each leg of my route? So the questions, or the handout, I know I have it here, gives you, okay, let me share it here. Let me explain it. So for our final plot, it gives you waypoint 1, 2, 3, 4, and 5. So plot each of these waypoints, and these waypoints are given to you with a bearing and a range from a point. So waypoint 1 is the Newport Harbor entrance buoy. Waypoint 2 is going to be half a mile bearing 025 from Long Point Light. Waypoint 3 there, waypoint 4. So we have given here our 5 waypoints. And then you guys are going to fill out the voyage plan. So our lat and long for each waypoint, our course made good. So what's the course that we want to make good? What's the course to steer? What's the distance and time estimated? So we're using that speed made good to get our time interval, distance to go, and excuse me, any notes. So this is kind of describing it below. But it gives you, what does it tell? Oh, okay. So it gives you the current. Our current is estimated to be that throughout the whole voyage. So we're just going to use that current throughout the whole voyage. And then it tells us we can either be on a sailboat under power making 5 knots, or on a power boat making 12 knots. So you decide which one you're on, and then create the voyage plan. And then we have a little bit of a quiz. So we'll go over this next week, but definitely try to work on that this week sometime. And then we're going to go into a little lecture on electronic navigation, mainly GPS. I added a little bit about navigating at night, and yeah, and that's a wrap. So
Thank you,
all right.
Bree.
You're welcome. Thank you guys for sticking with me.
Thanks, Bree. Have a
Very
nice
much.
evening. Bye.
All right. Bye.
Thank you, Bree. Good night.